Let's look at forming a stationary wave on a string. What are the conditions for forming a stationary wave on a string? How many notes, how many antinodes for a given frequency? As I start to increase the frequency, we see that at 9.0 Hertz, we have our first harmonic, the fundamental frequency. How many notes do you see? How many antinodes? Why do we have notes at the ends? Why do we have an antinode in the middle? What happens there? What will happen if I start increasing the frequency further? Could you have predicted this? The frequency for the second harmonic? What do you think the frequency for the third harmonic will be? So let's look at this. We now are on the third harmonic. We have 3 loops. How many antinodes? How many notes? Why do we have a stationary wave for this frequency with this setup? The vibrating length of the string is can we use the frequency of the third harmonic to work out the mass per unit length of the string? How can you check that the frequency shown by the function generator is correct? What equipment? What will you measure? Can you think of any safety considerations? Any hazards, risks? How can you deal with them? Can you write the formula for the first harmonic? Let's take it back. So 9.0 Hertz. We have recovered the first harmonic. There we go. Suppose we study the effect of length on the first harmonic. Can we use a graphical method to work out the mass per unit length? What are the advantages of using a graphical method? Suppose we keep the length constant and we change the tension. Again, locating the first harmonic frequency for each different tension. What kind of graph can be used to work out the mass per unit length of the string? Let's look at forming a wave, a stationary wave, in an air column. The length of the air column is 23.1 centimeters. I'm going to use a tuning fork with a frequency of, let's do this. Let's try that again. Okay. So what can you say about the wave in the air column? you can assume that this is the first position where we get a loud sound. Can you use this information to work out the speed of sound in air? How does that compare with the accepted value of 340 meters per second? Can you improve the accuracy of this experiment? How? Here we have a laser, a green laser, and we have a diffraction grating in front of the laser with 80 lines per millimeter. Light passes through the laser and we get a nice diffraction pattern. All these nice bright spots. Why do we have such a diffraction pattern? Now, this has been aligned so the zero mark is at zero, so the central zero order is at zero, and then we can see left and right, first, second, and so on orders. How can we use this data to find an accurate value for the wavelength of light? What do we need to measure? How would we measure it? Why does your method improve the accuracy in the estimation of the wavelength? Look carefully, let's see if we can zoom in. You can definitely see the different orders. So starting from zero and so on. What would be the effect if we change the light so it was not monochromatic? That's the next experiment. Let's have a look at white light going through a diffraction grating. So we have an LED ray box and we have white light, no diffraction grating. I'm going to add a diffraction grating with 600 lines per millimeter. So let's add it, let's see what happens. Can you suggest, can you predict what will happen? There we go, beautiful. So, we have a white fringe, zero order maximum. Why is the central fringe white? What happens to the secondary, subsidiary maxima? Why is the order of the colors what do you see on the screen? Let's just zoom out, zoom back in, there you go. Very nice. How about if I add a filter? This is magenta. Now magenta is 50% red, 50% blue. End result, magenta. So let's add it in. Can you predict what will happen before we add it in? Think about it. Filter goes in, and there you have it. What can you say about the fringe in the middle now, the zero order? What can you say about the subsidiary maxima? What can you say about the dark fringes? What must be true there in terms of path length, phase difference? Path length with respect to what?